So consider the next question. Okay. The next question. In piperidine, the hybrid state assumed by nitrogen. To find hybridization of organic molecule, check the number of group attached. Number of group attached around that atom plus number of lone pair around that atom plus number of negative charge around that atom. Okay. If this value equal to 2, then it is sp. If this value equal to 3, then it is sp2. If this value equal to 4, then it is sp3. Okay, this is a idea for finding the hybridization of organic compounds. So here they asked to find the hybridization of this particular nitrogen. So consider the groups attached on nitrogen. 1, 2, 3. So group attached on nitrogen is 3, which means the number of direct sigma bonds. Okay, 3 plus number of lone pair. We know that a nitrogen with a 3 valency have a lone pair. So a lone pair, and there is no negative charge. So the value is 4. So the answer is sp3. So the expected hybridization of nitrogen in piperidine, the molecule is said to be piperidine, that is sp3. Okay. So moving to the next question. The question, which of the following has fractional bond order? Which of the following has fractional bond order? Ready? So which one of the following have fractional bond order? We know that O2 have a bond order of what? 2. If it become O2 2 plus, its bond order become 3. If it become O2 2 minus, the bond order become 1. And we know for a fractional bond order, the total electron will be odd electron, right? So here F2 2 minus. So in this O2 2 minus and O2 plus, the bond order is a perfect whole number. In F2 2 minus, F2 have totally 18 electron. 2 minus means additionally 2 electron. So the configuration will be like a neon. So there won't be a fractional bond order. And H2 2 minus. H2 the electron is 2 plus 1 means 3. So here is a fractional means odd electron. So this will be the fractional bond order. Okay. The configuration will be sigma 1s2 less than sigma star 1s. So NB minus NA divided by 2, the answer will be 2 minus 1 divided by 2. The value will be half. Okay. Moving to the next. Ready? The next question, that is, listen to the next question. In O2 plus O2, O2 2 minus molecular species, the total number of antibonding electrons are respectively fine. Fine. So in O2, actually the configuration sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, and O2 follows the second order. Now 2s2p mixing, sigma 2p z2 less than pi 2p. I'm sorry, this is not star. Less than pi 2p x2 equal pi 2p y2 less than pi star 2p x1 equal pi star 2p y1. Okay, pi star 2p y1. Ready? Fine. Now, what is the number of antibonding electron in oxygen? O2. This is a configuration of O2. 2, 4, 6. So 6 antibonding electron is in oxygen. So if this is O2 2 minus, what is the change? If this is O2 2 minus, additionally 2 electrons here. Ready? If additionally 2 electrons is here, the number of antibonding electrons further increase to 8. If it is O2 plus, O2 plus means your O2 have 1 and 1 here. O2 plus means this electron lost from antibonding orbital. So the total antibonding electrons will be reduced to 1, 2, 2, okay, and 5. Ready? 2 to 5. So there is no choice regarding 5. O2 2 plus. O2 plus, fine. So what about the choices? Question number 33, the choices. Oh, I'm sorry. This is actually, this question, this is actually O2 minus. That's a mistake, okay? O2 minus, fine. That's a print, typing mistake. O2 minus means here is a 1 electron. So one more electron in antibonding orbital. So 6 plus 1, 7 electrons will be there. So this will be the choice, okay? This is not O2 plus, O2 2 minus. Ready? Next question. List 1 molecules, list 2 bond order. Select the correct code. Li2, Ne2, Be2, D. Okay. Li2, what is the bond order? We already written the configuration. Sigma 1s2, sigma star 1s2, sigma 2s2. So 4 minus 2 divided by 2, bond order is 1. So bond order is 1. Is there is any choice with bond order 1? No. Okay. So bond order is 1 here. Fine. Okay, wait. Let's find the bond order of N2. Bond order of N2 we know 3. Bond order of B2 we know 0. O2 we know 2. And this is 1. Okay, so N2 3. So 2 the choice is A. So is there any choice which 2 is matching with A? There are 2 choices. And 3 that is E. Okay. So 1 that is D and 4 that is 4 that is wait 3 is actually not 0. 0 3 is 0. 3 is 0 means 3 is D. Okay. So I think this will be 1. So 1 is C, Li. The rest are okay. O2 the bond order is E. So this is fine. So make the correction. 1 is C. Okay. Move to the next question. Among the following, the boiling point is higher for. This is alcohol, hydrogen bonding. This is alcohol. So there exists what? Hydrogen bonding. This is dimethyl ether. So weak dipole. Acetone, strong dipole. Chloroform, dipole. So anyway, the strongest interaction is in ethyl alcohol. So it may have greater boiling point. Okay. So the next question. Atomic number of 3 elements are given. +1 +2. Atomic numbers of 3 elements are. This is the question number 36. Atomic number of 3 elements are. Okay. A, B, C. Atomic number of element A. Element A is A. Element B is A +1. Element C is A +2. If C is an alkali metal, if C belongs to first group, then this is the group which is just just below the or just back of your C. That means this is in 18th group. So this should be in 70th group. So in a compound A and C, in a compound of A and C. So A is a halogen, C is a alkali metal. So the bond will be ionic. The next question, that is OH bond length in H2O is X Armstrong. So in your H2O, the OH bond length is X Armstrong. And OH bond length in H2O2. H2O2, you know, open book light structure. So what is this bond length? I think if you consider the value, and this have 95.7 picometer, and this is near in gaseous phase 95, and in another solid phase 98.8 picometer. So nearly these values are same. Okay. So if similar bonds which are present in different atoms, the bond length are nearly same. Okay. So we can represent it as chi Armstrong. This is chi angstrom. So this is will be also chi angstrom. Okay. If the very same kind of bond, for example, OH bond, even it is present in two different types of molecule, their bond length nearly same. Okay. If their hybridized state is same. Here the hybridization of this oxygen is sp3. In your H2O2 also, this oxygen is sp3 hybridized. Okay. So bond length will be nearly same. That is a common concept. Next question. The electronegativity difference between N and fluorine is greater than N and H. Fine. Then the dipole moment of ammonia 1.5 dpi and that of NF3 0.2 d. That we all know. We already discussed this question in the theory. In NH3 and NF3, the orbital dipole moment are in opposite direction. That's wrong. In NH3, orbital dipole moment along the direction of bond dipole. In NF3, orbital dipole moment along the opposite direction of orbital moment. And that is the answer. In NH3, orbital dipole moment and bond dipole in opposite direction. Sorry, both are in same direction. In NH3 as well as NF3, orbital dipole in same direction. That's wrong. In NH3, the orbital dipole and bond dipole are in same direction, where in NF3, both are in opposite direction. Perfect. Okay, that's a direct question. We already discussed that. Okay, so the next question. Which of the following pair of molecule have permanent dipole for both members? SiF4, if your silicon replaced by carbon, that is CF4. If fluorine replaced by hydrogen, the geometry will be same. And you know, this is a pure tetrahedral geometry, dipole moment will be 0. Where the question, both members should have permanent dipole moment. Here the dipole moment is 0, so this choice is not possible. CO2, the structure is linear, perfect geometry, linear, the dipole moment is 0. So this is not okay. SiF4, once again, these two are 0 dipole moment. So this will be the answer. NO2, the shape is angular. And ozone, the shape is also angular. So the perfect answer is C. Both have angular imperfect geometry. So net dipole moment will be there. The next question. The strength of bonds 2s, 2s, 2p, 2p, 2s, 2p, 1s, 1s. Okay. So what about the strength of bonds? If we consider the strength of bonds means here they are mean the formation of what? Sigma bond. Formation of sigma bond. Ready? So actually the question, okay, this is actually 1s, 1s. Okay, fine. We know that if n is same, PZ overlapping having more extent than SPZ than SS, if n is same. So in case of this, the order will be like this: 2p, 2p greater than 2s, 2p greater than 2s, 2s. But this is a shorter orbital, so that orbital overlapping will be much greater than the second one. Okay, so here n is lower. If n is lower, the strength is higher. Ready? Fine. Next question. Which of the following is the correct state with the reference formula hybridization central atom? CO2 that is sp2 bend, that is wrong. CO2 that is sp linear, H2O that is sp2 bend is okay, but H2 have sp3 hybridization. BCl2 sp linear, fine, perfect. You know how to find the geometry and shape, that is already discussed. H2O sp3 linear, sorry, this is bent. So the choice is C. Okay. Next question. Which of the following is correct about O2 plus? Paramagnetic and bond order less than O2. O2 the bond order 2, O2 plus the bond order 2.5. O2 and O2 plus both are paramagnetic. So paramagnetic bond order greater than O2. It's not diamagnetic. The choice is B. 44, the choice is B. Okay. Move to the next question. What is the correct sequence of bond order? That we know. Here is actually O2, O2 minus O2. So this is answer. That's a direct question. I think no need of explanation. The force responsible for the union of two ice blocks as a single block is hydrogen bonding. Okay. Due to hydrogen bonding, when two ice blocks are combined, they become a single block. Okay. Fine. The next is, which of the following geometry is not possible when the central atom is sp3 dehybridized? sp3 dehybridization either trigonal planar or seesaw or linear or T-shape. Trigonal bipyramidal, that's okay. It's not trigonal planar. I'm sorry, that's wrong. These two are okay, possible. So the geometry which is not possible is trigonal planar. Easy direct questions. Next question. Which of the following statement are correct? Hybridization found in cation of solid PCl5 is sp3. PCl5, solid PCl5 which exists as PCl4 plus and the anion exists as PCl6 minus. So in PCl4 plus, what is hybridization? So let me find the total valence electron. 5 plus 7 into 4 minus 1. I think this is 32. 32, it will be 4 and 0 bond pair, lone pair, hybridization sp3. So this statement is perfectly okay. AB to L2. AB to L2 means shape of water, right? The BAB bond angle is greater than normal tetrahedral bond angle. That's wrong. Since there is a lone pair, angle will be lesser, right? Yes. ClO3, NH3, XCO3 hybridization and the number of lone pairs are of the central atom are same. ClO3, the total valence electron, 7 plus 6 into 3 plus 1. The answer is 8 plus 6 into 3, 18, 8 plus 18, 26. NH3, 7 plus, I'm sorry, NH3, that is not 7. Nitrogen, the valence electron 5. 5 plus 3 into 7, that's also 26. If the valence electrons are same, then hybridization lone pair all are same. Okay. XCO3, xenon have 8, oxygen 6 into 3. So that's 26. So that statement is okay. All have same valence electron. So all will be belongs to 3 bond pair, 0 lone pair with the hybridization of sp3. Thus that is perfect. In discrete P4 molecules, there are 6 pp bonds and 4 lone pair electron. Okay, 6 pp bonds and 4 lone pair electron. Ready? So the P4 cage like structure. Sorry, this is not the structure. Okay, let me draw this here. A phosphorus, a phosphorus, 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 a bond, a bond, a bond, a bond, a bond, a bond. So there are 6 bond pairs and each phosphorus is having 3 bonds surrounded. So 2 a lone pair will be the, so 4 lone pair, 6 bond pair, 6 pp bonds, 4 lone pair. That's also correct. So the only wrong statement is 2. Okay. So 1, 3, 4 are correct. 2 is the wrong one. Okay. Next question. Which of the following pair have same bond order? One with the same bond order. F2O22 minus, that have same bond order because both have 18 electron. N2CO2. Into the bond order is 3. Okay. CO2, the bond order is between carbon is actually 2. O2O2 minus, no, N2N2 plus. So this is perfectly okay. Enough. Here's the answer. Next question. Which of the following statements are correct? As S character of hybrid orbital increases, S character of hybrid orbital decreases. So consider an example, sp2, sp2, sp3. From left to right, S character decreases. Okay. So bond length increases, bond energy decreases. What about the bond angle? Bond angle 180, 120, 109, bond angle decreases. Fine. So now answer the questions. Bond angle decreased. That's correct. Okay. Bond strength increased. No, bond strength decreased. Bond energy decreased means bond strength decreased. Bond length increased. That's correct. So this and this are correct. So choice A will be the answer.